Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to my lecture. So today we are going to talk about budget constraint, and here budget can also be considered as resources. So how we understand budget and how we measure budget when we have limited resources, and if we have two commodities, then how should we frame the budget line. So there are different properties of the budget line or budget constraint that we will try to understand in this lecture. So in our previous lecture we tried to explain the utility and then preferences with the help of indifference curves, and then we also tried to understand different properties of indifference curves and indifference maps. And today we'll try to understand how to optimize our utility through indifference curves at the given budget line or when the resources are constrained. So let's first begin with the budget line and its slope and its properties. So let's have again the two commodities here, like say commodity X and commodity Y, and then price of commodity X is determined by Px and price of commodity Y is determined by Py. So when we take the product of Px X, is basically we are considering the value of X. Likewise, when we take Py and Y is the value of the Y. So if we are considering only two variables or two goods like X and Y, and keeping all other factors constant, then the total budget to produce or to demand X and Y will be Px X plus Py Y will be equals to M. And here M is the total amount of resources that are available to consume, and therefore M is the fixed and my total budget cannot cross M. So it is either equals to or less than equals to total budget, which is M. So now if we draw this budget line and linear wise, so one can also write this equation as say Py will be M minus Px then X. One can also write as Y equals to M by Py minus Px by Py and X. So one can write this way, and likewise we can also write, like say this is equation 1 from the budget line. Likewise we can also write X is M by Px minus Py by Px y. So this is also can be right, like say as equation. So let's draw the budget line here. So suppose we measure Y along with the vertical axis and X along with the horizontal axis, and then this budget line will be the straight line linear function. You can see, like say this equation is a linear, and this straight line is Px X plus Py Y, which is equals to M, right? So this is the budget line. So there are 2 points here, say at point A and here at point B. So AB is the budget line, and at point A it is basically when x equals to 0, then what is the value of y? So it's like m by py. Likewise, at point B, what is the value? Like x will be m by px when y equals to 0. So this is what the two corner points that we get it. So now try to calculate the slope of budget line. Like, why do we calculate slope? Is basically try to understand the change in one commodity due to one unit change of other. So here, for instance, if I want to understand the slope of budget line, like delta y by delta x, so here it's like from equation, say from equation 1, like say dy by dx is equals to minus px by py. We can also write like minus dy by dx to have p equals to px by py. So this minus is nothing, it shows the negative or downward sloping of the budget line. So here budget line, slope of the budget line is equals to px by py. So now let's have couple of properties and what are the factors on which budget line becomes sensitive and response and budget line is changed. So let us also understand that. So now, which are the factors which actually make budget line sensitive? One is when income of an individual changes. The other one is when price of the commodity changes. So let's first take the example of when income changes, right? Like, again we can write the budget line like px plus py, y equals to m, and now p price of the x or price of the y or quantity of x or quantity of y are remain unchanged, but then income, like here total budget, like total income, because budget is a proxy, can be considered as a proxy for the income. So if income increases, definitely budget, if x and y are normal goods, then my tendency or any individual's tendency to consume more x and y will also be increased. So therefore if income increases, definitely budget also will be increased for x and y if x and y both are normal goods. So suppose budget line increases with the increase of income, say from increases from m to m dash, where m dash is higher than m. So how budget line will look like? So earlier budget line, say here on the horizontal axis x and y. So again we are kind of presenting following two commodities, and then here say budget line AB, where m equals to px x plus py y. So now suddenly income changes and therefore budget line also increases, and then this will shift parallelly, and then we get new budget line, say a dash b dash, where budget line can again be py y. So when income of an individual changes, then budget shifts parallelly, If income reduces, then budget line will also will be decreased. If income decreases, and it will come downward than the original position of AB. Likewise, if total GDP is high, and GDP, as we said, that is an outcome or the income, national income. If GDP increases, budget for say investing on the road infrastructure also will be increased, or budget towards say building new schools, hospitals also will be increased. So therefore, if output increases, then budget for those commodities also will be increased, and therefore budget line also will be shift upward in case of expansion of the output, or in case of output, if output decreases, then budget for certain commodities also will be decreased. So this is how at the individual level, for commodities, budget will be changing when income of individual changes. Likewise, for the national income, and then budget for other socially relevant commodities or physical infrastructure also will be changed. So now let's move to the next set of case. And here, as I said, that one way in which budget will be budget will be sensitive or will be responsive is like through changes in the income. The second indicator on which budget becomes very sensitive is the changes over prices. Like when price changes, for example, suppose a good becomes expensive, like say price of X or Y increases, then how that will be that will be responsive, especially how that will impact on the budget line. So suppose we take again the same equation like budget line, then we can take like say Px x plus Py y equals to M, original equations. And here suppose X becomes expensive. What does that mean? It means price of X is increasing, right? So here the first component, say we can say that equation 1, the original budget line. So suppose Px, value of Px increases, therefore Px and X, this particular component also will be increased, right? So let's see how it goes graphically. So here on the vertical axis, again we measure Y, and then on the horizontal axis we measure X, and this is our original budget lines, AB, which represents M equals to Px x plus Py y, and then suppose Px increases, but then other points remain constant. Like from equation 1, one can also write as like x equals to M by Px minus Py by Px y, right? So one can also write this way. So what is the slope of the original budget line? We already know its slope is like dy by dx. Original slope is minus px by py. So if px increasing, like say now we have px bar, which is higher than px, and then the slope will become minus px bar, like similar dy by dx will be equals to minus px bar px dash by py. So here it will become more stiff, like say b dash, and we have, because value of x bar is increasing, and here like say on the corner solution here m by px, and here m by px dash. So here at point b dash, overall value of m by px will be less because price of x has become expensive, and therefore budget line, slope of the budget line will be much steeper when a good, like here in case of x is like x has become expensive. So it will, budget line will move inward because budget line is becoming more stiffer than the original budget line, say a b. So a b dash is certainly steeper than a b. Why? Because px is more, and therefore m by p ratio is becoming less, and therefore it has become stiffer than the original budget line. So now let's talk about the optimal choice and utility maximizations. So we already understood that how utility is measured through indifference curve, and utility is like our level of satisfaction that we are drawing from say x and y, and then and this can be unlimited, and then with the limited resources, and here limited resources like say budget line, and then how we can or one can optimize its utility given the budget constraint. So now like say our utility function, like here again we are considering two commodity, and here our objective is to maximize our utility, but then of course subject to our budget line, which is px and x plus py y equals to n. So our tendency always will be to maximize our utility subject to the budget constant, where m is constant. So either total will be total budget could be either m or less than m. So now from MRS, like from the slopes point of view, from marginal rate of substitution point of view, like MRS, for x and y we got mux by muy, which is minus dy by dx. So that is how the slope of indifference curve that we got it. This is from utility function, right? From budget, from the budget line we get minus dy by dx equals to px by py. So here that we get, like say this is say from utility, equation 1 we get, and then equation 2 we get it from the budget line. So now if we draw this, if we take y on the vertical axis and x along with the horizontal axis, and if we draw say resource is scarce and therefore we have limited budget for that, and this is the budget equation pxx plus pyy equals to m, which is constant, and then slope of this budget line is px by py, and say this is my utility, which is the function of x and y, and then at point say E, where marginal rate of substitution xy is becoming equals to like mu x by mu y is equals to price ratio, and this price ratio is coming from budget line, and this ratio between marginal utility of x and y is coming from utility. So at this point, at point E, like I will be indifferent at any point on the utility curve because my utility is constant from any point on the utility curve, but at point E with my budget, this is becoming I'm optimizing my resources, and I'm also getting my satisfaction level highest at the given budget line. And here the ox star amount of optimum level of x, and oy star is the optimum level of y that we get it. So this is E is the conditions of the optimal choice and utility maximization. And if my utility curve is just like this, then is basically it is I'm underutilizing the resources that is available. And if my utility curve, which can go up because that is for the rational thing, like higher utility will give higher level of satisfactions for any rational human being, always will aspire to be on the higher utility curve, and therefore I will derive much more higher utility from the higher utility curve. But then budget is constant, and therefore my optimization is not happening even with the higher utility curve, like say U1. So this is what the mathematical expression of optimization conditions of utility and budget. And now let's move to utility maximizing choices for special types of goods. And these 4 special types of goods that we already had taken into account in our previous lecture in context of utility. So now there, like useless goods, like say if I consider vertical straight line and here y and x, and we are assuming y is neutral, and then suppose budget line. So budget with any sort of combinations, there will be like say there will be one solution, like here say budget line a b. So at point b where utility is getting optimized. Even in case of other special cases, like in economic bad, which is like like say this utility curve that as we already know, and then here is the budget line. So here say in at point again b, utility is getting optimized. In case of perfect substitution, like say utility curves are this, but then if budget line is this, again say budget line is a b, and again at point a utility is becoming optimized. And in case of perfect complementary goods, say this one is budget, like say budget a b, and then say at point say e is becoming sort of utility is becoming optimized. So but in all this diagram, along with the horizontal axis is x, and on the vertical axis it is y. So even in special cases or special types of goods, even special set of utilities, budget also can be with a given budget, utility can be sort of optimized. So here I'll stop this lecture, and for this particular lecture, I again recommend Holler variant of the selected chapters, especially on budget and optimizations, and also initial selected chapters from Jonathan Gruber book on public finance and public policy. So thank you very much for your attentions, and I'll see you in my next class.